Dear learners, I welcome to this video lecture number 9 in Unit 4 of the subject Air Pollution and Control Engineering. In the Unit 4, we are going to see bioscrubbers and biofilters. Bioscrubbers. Bioscrubbers or biological scrubbers are the biological reactors used to remove volatile organic compounds and odorous molecules like H2S and organic sulfides present in industrial gaseous emission. Working. It consists of gas scrubber and a biological reactor to remove the components which are absorbed from the gas stream by the wash water in the gas scrubber. The biological reactor contains an aeration device to supply bacteria with enough oxygen to break down the components. In the biological reactor, the pollutants that have been absorbed by the wash water are biologically degraded. The purified scrubbing liquid is circulated to the scrubber where it is able to reabsorb the pollutants. The biologically degraded hydrocarbons are converted into H2O and CO2 in the bioscrubbers. The non-degradable hydrocarbons remains in the wash water. Components such as H2S and NH3 are converted into sulfate and nitrate respectively. Regular drainaging needs to be takes place in order to keep down the salts content and the level of non-degradable hydrocarbons. This can be takes place on the basis of conductivity or through fixed discharge method. The scrubber must have a special open packing and a spray nozzle to prevent blockage by biosludge. Beside a carbon source like hydrocarbons, the biological system also needs nutrients in order to survive. For this purpose, a mix of nutrients is added to the bioscrubber. This mix of nutrients contain nitrogen, design and efficiency. The level of discharge is determined by the flue gas composition, the hydraulic residence time of wash water of 20 to 40 days produce good results. The gas scrubbers must be designed to ensure that the residence time of the gases in the scrubber approximately 1 second. This may be slightly more or slightly less depending on the solubility of the component. This table shows the various pollutants and the removal efficiency of the pollutants by bioscrubbers. For the pollutant volatile organic compound, the removal efficiency is 80 to 90%. The odor removal efficiency is 70 to 80%. The ammonium removal efficiency is 80 to 95%. Restrictions to use bioscrubbers. The following factors should be considered. Bioscrubbers operations to get higher efficiency. Pollutants must be water soluble. Pollutants must be biologically degradable. There must be a relatively consistent emission supply. Conductivity may be maximum up to 5000 ms per cm. The sludge concentration can be maximum, which is 15 gram per liter of dry substances. Atmospheric pressure should be maintained. POC should be 100 to 1000 milligram per meter cube. Ammonia should be 50 to 200 milligram per meter cube. Advantages: very good biodegradation of components, high concentration of easy to degrade components can be processed, high concentration of acidifying sulfur, nitrogen, and chlorine components can be removed with high pH. Due to large quantity of water, peak emissions are better dealt with the biofilters and biotrickling filters. Disadvantages: primarily suited to soluble components only. Components must be biologically degradable. Production of sludge, which must be disposed of. Discharge water requires further treatment. Applications: removal of odor and sulfur component from flue gas in the rubber industry. Removal of odor and sulfur components from flue gas in the production of methanol. Removal of odor in the production of polymers. Removal of odors, hydrocarbons, and nitrogen components during the processing of paint residues. Treatment of flue gases coming from waste sites for dangerous substances. Ammonia removal at cattle farms. Solvent problems when alcohols, ketones, acetates are used. Removal of other components like NH3 and H2S from gas originating from water purification plants. Removal of odor rising from the production of enzymes.